Effect of hip abduction assistance on metabolic cost and balance during human walking. We designed a hip abduction assistance system and examined its impact on reducing physical exertion and enhancing dynamic balance. Hip abduction was assisted by applying lateral torque at the hip joints through a cable transmission system. The cable's anchoring points were located on the lateral aspect of the thigh, and both these points and the waist belt were aligned with the body's vertical axis while in a standing position. Consequently, when the actuator is engaged, it pulls the Bowden cable, thereby generating a torque that effectively aids in hip abduction. Hip abduction is the act of moving the leg away from the body's midline. We design an assistance profile for hip abduction by mimicking the hip joint's positive moment and power in the frontal plane. We configured 4 different assistance profiles for hip abduction, each based on varying peak timing. These profiles are labeled as Moment First Peak Mimic or MF, Power First Peak Mimic or PF, Moment Second Peak Mimic or MS, and Power Second Peak Mimic or PS. The study was conducted on a treadmill with a tethered actuation system positioned behind the participants to provide actuation forces via a cable. Participants were outfitted with a set of monitoring devices including load cells, IMUs, a respirometer, a motion capture system, and marker sets to track various biological changes in response to the assistance provided. This video presents our hip abduction assistance system. The participant walks on a treadmill, receiving hip abduction assistance while collecting respiratory and kinematic data. For instance, in the MS condition, which mimic the second biological moment peak, actuation starts after mid-stance. The maximum assistive force is set at 300 newtons. We evaluated the performance of the hip abduction system across 4 distinct assistance timings: MF, PF, MS, and PS, with a cohort of 10 participants. Compared to the baseline of normal walking, the MS condition demonstrated a significant reduction in metabolic cost by 11.61% in a single-day protocol.